Alright, Matrix, we're going to be looking at activity 8.3 on page 163 now. So, let's have a look. Grab my textbook and we can have a look at the first question. These are all to do with measuring volumes and capacities, and in particular they're going to be dealing with a lot of things where we're dealing with grams per or mils per capacities and things, kilojoules. So, first question. The energy content of margarine is 3,000 kilojoules per 100 milliliters, and that of peanut butter is 2,610 kilojoules per 100 milliliters. Determine the number of kilojoules in 5 mils of margarine, and then we've got a situation where someone's eating some bread and putting some peanut butter and things on it, but we'll deal with that in a moment. Okay, so let's take a look at number 1A. So 1A, we're told that the energy in the peanut butter, we need 5 milliliters of it. 1 gram or 100 mils of it is going to have 3,000 kilojoules. So I'm just going to take 3,000 and divide it by the 100 mils. So that will give me my 150 kilojoules of energy in 5 milliliters of margarine. Okay, B, we're going to take a look at the person's situation here. So, let's see, they want to eat a slice of bread. It's 225 kilojoules per slice of bread with 5 mils of margarine. We've already calculated the energy for that. They don't want to use more than or maximum of 850 kilojoules of energy. So that's our maximum that we're allowed to use. So we can have 850 kilojoules. We're eating one slice of bread, which we were told is 225 kilojoules, and we're also taking off the 150 kilojoules from earlier. Okay, that means that they have only got 475 kilojoules of energy that they're allowed to still consume from peanut butter. Now, the 475 kilojoules that we have here, we need then to divide it by 2,610, which is the energy in 100 milliliters of peanut butter. Okay, if we divide it by that amount, we are going to get 18,2 milliliters of peanut butter. And realistically, no one's going to be measuring 0.2, so we'd probably round it to 18 milliliters of peanut butter that they would be allowed to eat. Alright, then let's move on to question 2. Question 2 is looking at a construction. Now we're going to be using a bit of our area and perimeter and all that nonsense and volume here. The foundation trench for a wall is 40 meters long, has a width of 75 centimeters and 50 centimeters deep. If a wheelbarrow has a capacity of 25 liters, how many wheelbarrow loads of concrete will we need to fill the trench? So I need to convert these three into liters so that I can find out how many times 25 goes into it. First things first, be very careful. They've given one of the measurements in meters and the other two are in centimeters. I'm going to use centimeters here because I know that there are 1,000 cubic centimeters in 1 liter. So let's work out using centimeters then. So I have 4,000, which is the 40 meters times 100, gives me 4,000 centimeters, multiplied by 75, multiplied by 50. That is going to give me 15 million cubic centimeters. I know that there are 1,000 cubic centimeters in a liter, so if I divide that by 1,000, I'm going to get 15,000 liters of concrete. that 15,000 litres needs to be divided by 25 litres, which is in one wheelbarrow. That gets you down to 600. So therefore we have 600 wheelbarrows. 600 wheelbarrow loads worth of concrete in our trench that needs to be dug. Okay, moving on. Number 3. The alcohol content of a certain kind of beer is 5% alcohol per volume. So that basically is telling you that 5% of whatever your volume is going to be alcohol. If Glenda drinks one can of beer with 330 milliliters, how much alcohol does she consume? This thankfully is a very straightforward sort of thing. We just need to find 330 milliliters and multiply it by 5%. That gives you a result of 16.5 milliliters of alcohol being consumed. Fine. Number 4. I know I'm going quite quickly, but some of these are quite straightforward. The sugar contents of a soft drink is 26.5 grams per 250 milliliters. If 1 teaspoon of sugar has a mass of 4 grams, how many teaspoons of sugar is in a glass of 300 milliliters of soft drink? Give your answer correct to the nearest whole number. Fine. So, let's take a look at that. So, we're told that we are using a 300 milliliter can of juice. There are 26.5 grams of sugar, milliliters of sugar per 250 milliliters of, it is 200, these grams, 26.5 grams of sugar per 250 mils of cool drink. So we find out that we have 31.8 grams of sugar in this. Now, we need to use our calculations here, because they tell us that 1 teaspoon of sugar weighs 4 grams. They want to know how many teaspoons we're using. So 31.8 grams divided by 4 grams will give me the 7.95 teaspoons. They asked us for the nearest number, so it's 8 teaspoons. 8 full teaspoons of sugar will be consumed. Okay, I'm going to move on to question 5. I think I'm going to use a new page for that one. So, question 5. It wants us to compare 2 things here. Canola seeds are used to make oil, so we're talking about canola oil here. You can buy a 750 milliliter bottle of canola oil for R9.95 or a 2 litre bottle for R23.99. For each bottle, calculate the cost per milliliter of oil. Okay, so I'm going to call them my big bottle and my small bottle. It's probably the easiest thing to do here. So a small bottle. The small bottle has 750 milliliters in it. Alright. And it's R9.99. So I'm just going to take my rands because they want cost per mil. So I'm going to take R9.99 and divide it by 750. Let's use the calculator here. Oops, too wrong. We are going to get, and I want you to give me all the decimal places here. 1322. Okay. That's rands per milliliter. For the big one, we're looking at 23.99 for a bottle of 2 litres. Those 2 litres are going to give me 2,000 milliliters. So, simple enough here. 23.99 divided by 2,000. It's going to give you 0,0119995 per milliliter. Okay, they didn't ask you for rands or cents or anything like that. They just asked you the cost per bottle, so that's what I've done there. The next question asks you which bottle is the best to buy. Well, if we compare these two prices, I would say the big bottle. The big bottle is cheaper. Is best, it is the cheapest. It's not cheapest by a lot, but it is the cheapest one for us to use here. Good. Moving swiftly onwards, number 6. Now, question 6, they're going to confuse you with a lot of reading. They're talking about how they've got a test for certain protozoa and so on, and now you're looking for E. coli. The important thing is here, the concentration of E. coli is measured in CFU per 100 mils, where CFU stands for colony forming units. Drinking water must be less than 1 CFU per 100 mils, and if you're going to go swimming, you need it to be less than 125 CFU per 100 milliliters. A 5 milliliter sample of water is taken from a dam and contains 2 CFU. Calculate whether it's safe to drink and whether it's safe to swim in. I'm actually going to do the calculation altogether and then make the determination of whether or not it's safe. So, I know that I have 2 CFU per 5 milliliters. Right? If I wanted to convert that to a unit that I can use, I could change this to a common thing. So they were quoting everything per 100 milliliters, so I need to see how much this would be. So if I take 100 and I divide it by 5, I get 20. So that would mean that I would have to multiply both the top and the bottom by 20 to get it as per 100 milliliters. So per 100 milliliters, if I multiply 2 by 20, I get 40 CFU. Okay, so now I've got 40 CFU per 100 mils. So then I can answer this quite clearly. Is 40 CFU less than 1? No, it's definitely not. So no, the CFU are too high, alright, for this one, or it's more than 1 CFU per 100 milliliters. Always make reference back to the thing that they've given you, okay? If they've given you some sort of measurement, you need to use it, please. Okay, then this other one is 40 less than 125. Yes, it is, so it's safe to swim in. So it's, yes, it's less than the 125 CFU per 100 milliliters. Okay. Alright, number 7, they've asked you to play around with some cups and things to figure out the measurements. Obviously you can't do the eggs or the lemon because those are solid units. Otherwise you've got teaspoons, which are 5 milliliters, measuring cups of 30, 60, 80, 125 and 250 milliliters to measure out the ingredients. So we're going to try to do the least amount of washing up here, so we'll use the least number of things. So for the margarine, okay, if I took a 30 milliliter and a 60 milliliter cup, I would get 90 mils. I need another 10, so I could use 2 teaspoons as well. Remember, TSP is shorthand for teaspoons. Okay, same thing with the baking powder. I only need 5 mils of that. So that is quite easy. That's 1 teaspoon for my baking powder. I spelt powder, whoopsie, I'm sorry about that. Alright, my handwriting is getting a little bit rushed. Okay, for my sugar, they asked me to use 90 mils of sugar. I think that a 30 milliliter and 60 milliliter cup measure will be sufficient for that. Flour, you could go and take the 60 ml measure and use it over and over, but it is actually more sensible for you to use the 80 milliliter one that they've had. So you can take the 80 ml cup measure and multiply it by 3. So you're using it 3 times over. Okay, and then with the milk, we're going to look at 500 milliliters for that. So that's just going to be 2 times the 250 milliliter cup measure for that. Alright. Alright, now we're going to need to move on to question 8 now. So let me just turn over the page so I've got some more paper. Okay, so question 8 says we want to prepare 4 glasses of 330 milliliters of juice. Okay, fruit juice. The fruit juice concentrate is to be diluted in a ratio of 1 to 5. Right? If Caesarware prepares all the juice at the same time, how much concentrate and how much water must be mixed? We first want to work out what the volume of everything is together, and then we can work out the rate, using the ratio, how much would be used. Okay, so number 8. You're going to first work out that he is going to be preparing 4 glasses of juice, so that's going to give you 1,320 milliliters. Okay, I'll just put the milliliters in there because it's useful. So now, concentrate. I'll concentrate. We're going to be taking our 1,320. Now, just a little side note, I know that a ratio of 1 to 5 is going to give me some sort of ratio of things over 6. So it's 1 over 6 and 5 over 6. Alright, you add those two numbers together to get that ratio. Okay, that's, just keep that in mind. So, if I multiply that by my 1 part in 6, I'm going to have 220 milliliters. With the water, we're going to be using 1,320 times 5 over 6, because 5 parts there, alright, and that's going to give me 1,100 milliliters of water. Okay, then B. Caesarware decides to pour the concentrate into each glass and fill it up with water. Calculate how much concentrate will be needed for each glass. Give your answer in milliliters and liters. So, using our answer from over here, the 220 milliliters, if I take 220 milliliters and I divide it by the 4 glasses, I will get 55 milliliters. Question did also ask us for the answer in liters, so we know that there are 1,000. I know there are 1,000 mils in a liter, so we're going to be looking at 0.055 liters in total. Alright, hopefully that's good, and good luck with the rest of this.